All right,
This
so
video is going to
gonna
cover two parts of the math
for labor markets in terms of least cost combination of resources and profit maximization. Something we're much more used to is this idea of profit maximization, where you're going to hire workers and capital as long as their benefits exceed their costs. So this goes along with what, for now at least, is page 10 in your packet. It might be a different page. So we look at this profit maximization combination, and so what we're really looking at in products markets, we talked about MR equals MC. That's what maximizes profits. In labor markets, they just call those things different. So we're going to use the rule MRP equals MRC. Or at least you're going to hire until MRP is greater than or equal to MRC. So when we look, the price of the good is $2 in this example. And we have two things. We have labor and we have capital. Labor has a price of $16. That's its cost. So that's the MRC for all units of labor. So we're going to hire until the MRP dips below that. And the price of capital is $55, which is that resource cost. Each additional capital we hire is going to cost us $55. So to calculate the MRP for each, we just simply take the marginal product times the price, which is 2, which makes the math pretty easy. So 32 times 2, so 64, 54, let me zoom in. We have 54, we have 46, 30, 20, 10, and 5. So in terms of hiring, we're going to hire this first unit of labor because its value is greater than its cost. We hire the second unit for the same reason, the third, the fourth, the fifth, not the sixth, not the seventh, because that's when the value, the revenue product, falls below the cost of labor, which is $16 in this example. So we would hire a total of 5 laborers in this example. Over on the capital side, we have the same price of the goods they're producing. So this piece of machinery has this kind of production function. And we're going to calculate each unit of capital's MRP using the same equation of MP times price. So 40 times 2 gets me 80. And then 70, 60, 50, 40, 30, 20. And we're going to hire the first unit because now the cost of each unit of capital is 55. So the value is greater than the cost, value greater than the cost, value greater than the cost, and no. This is where it falls below. So we're going to hire 3 units of capital in this example. So to finish filling out the page and answering the questions, we're going to hire 5 units of labor and 3 units of capital to maximize profits. The revenue of hiring capital and labor would be, well, they produce 107 quantity times 2 would give you 214, plus 105 times 2 gives you 210. So that's going to mean $424 is our total revenue of hiring labor and capital. And the cost of that is going to be the 5 times 16, which is 80, and the 3 times 55, which is 165. Added together is 245. And so when you subtract that to make profit of revenue minus costs, you're going to get a grand total of $179. And so that would be the amount of profit made from this example. So again, profit maximization is something we're used to. The idea that we're just going to hire as many units of labor and capital as is profitable based on what their price or their cost is. All right, moving on to least cost combination. So in this case, the dynamic works a little bit different. You're trying to find the least cost combination of hiring, in this case, labor and capital, in order to fill the order for 210 units. So your company gets hired and they have an order come in for 210 units, and you're trying to find the cheapest way possible because your total revenue in this case is going to be fixed. So your total revenue is guaranteed to be $840 from selling 210 units at $4 a good. So you have to decide what the cheapest way of producing it is, so that way you as the entrepreneur have the most amount of profit. So in order to find least cost combination, you're looking at kind of efficiency. versus the cost. So just like before with milk and cookies, you're looking for the most bang for your buck. In this case, it is the marginal productivity per dollar spent on that unit of labor and capital. So in this case, we're going to take the marginal productivity of each unit of labor and capital, dividing by the price of each. So that is kind of the most productivity per dollar spent on labor and capital. So as we go through, we're taking the marginal productivity, 32, divided by the price of labor, which is 8. So as we go down this row, it's 4, 27 divided by 8. So the key with this is you're not dividing by the price of the good, it's the price of the labor. It's the price of the capital. So as we go through, I'm just going to kind of use simple rounding because it won't matter too much. So 3.4, 2.9, 1.9, 1.25, 0.6, and 0.125. So again, it's marginal productivity per dollar spent on labor. Obviously, the more the better. On the other side with capital, now the price of capital is 15. As you can see, it's in general more productive, but it also costs more from the standpoint that the price of capital is 15. So as we go down this list, $3.2, 3, 2.3, 2, 1.7, 1.3, 1. So again, I'm just taking this column divided by the price of capital. So as we go through, we're trying to fill up our order. Now what we're going to do is make decisions about what to hire first and next and so on. All right, so now we're going to use these columns to take a look and make actual decisions about what we're going to hire in what order. So again, we're looking for the most value per dollar spent, so we're looking for the higher number. So we're looking at L1 versus C1, so 4 is greater than 3.2, so the first decision is we're going to hire labor 1 with a marginal productivity of 32. Keeping track of our order, that means our total quantity is also 32. Then our next decision is the first unit of capital, 3.2, versus the second unit of labor. So we're going to go with L2 because that's, again, 3.4 is greater. So marginal productivity is 27, and then total productivity would be 59. Then we look, and 2.9 versus 3.2, so we're going to hire C1, which makes 48, and that'll bring our total to 107. Then we're going to hire the next unit of capital, C2. Marginal productivity of 45, bringing our total to 152. Then our 2.9 is higher, so L3 is what's going to be hired next, giving us an additional 23 units, pushing us to 175. And then lastly, we are going to hire the C3 because 2.3 is greater than 1.9, which gives us a marginal productivity of 35, getting us to our 210 order number. So we've kind of filled our order with 3 units of capital and 3 units of labor. So the total cost of hiring that labor is going to be $24. The total cost of capital hired, because we hired 3, is going to be $45. So we add those together. The total cost is going to be $69. And then the revenue we already had figured out was $840. So profit would be $840 minus 69 is going to give us a profit of $771 is the most amount of profit. Now, if we just went through and just kind of said, well, let's just hire some labor and some capital, we're going to end up with a lower profit value. But as from a profit maximization standpoint, even though it's not the profit maximizing way of doing things, it is filling this order in the least cost combination, we are still looking at the greatest amount of profit for the entrepreneur is that's why they get into business. So the key is that it's the marginal productivity per dollar spent on that unit of the resource. In that case, labor. In this case over here, it's the price of capital.